Okay, so I'm going to attempt to make a video to talk about the types of reactions that can happen between the different organic compounds. So at any point during the video, you can just pause it and you can be carrying this out yourself on a blank piece of paper. Some of you have gone through most of this in class, but there was quite a good few of us out, so I'm just going to do it again. Okay, so far we have these different organic compounds. At this stage, you should be familiar with their functional groups, and you should also be familiar with what shape they are. If you're not, pause this and go back and check that before you start. So first thing we're going to do is I want you to have a think, and I want you to highlight any of these organic compounds that are tetrahedral. What you'll notice is the ones that are tetrahedral are ones that have no double bonds present in them. So if you want to do that now. Okay, and you should notice that it's the alkanes, the haloalkanes, and the alcohols. They're all tetrahedral. Okay, they've no double bonds. All the rest are planar. Right, I now need you to think of the different types of reactions that can take place and make a key for it in the corner using different colours for each type of reaction. Okay, and you can see that the different types of reactions are addition, substitution. You've got your redox reactions, so oxidation and reduction, and elimination reactions. Okay, so first of all, we are going to add arrows from any of these organic compounds to other organic compounds where an addition reaction is taking place. So addition meaning adding something. So normally this involves breaking a double bond and adding something across that double bond. So have a think and add it in with your colour red I've used, and I'm going to do the same. So if you have a look here, that's alkenes with the double bond changing to alkanes, single bond, haloalkanes, single bond, polymers, lots of single bonds all added together. You've got the alkynes, that's your triple bond changing to alkenes, double bond. And then you've got this one, alkenes changing to alcohols. That is breaking the double bond and adding water across it to make alcohol here. So all of those are addition reactions. Okay, so we're going to do the elimination reaction for next. The only elimination reaction on the course is your mandatory experiment, alcohol going to alkene. So it's called a dehydration reaction. We're going to take away the water. Okay. Right, so then we have our oxidation and reduction. This was your mandatory experiment. We use the aldehydes and the ketones. Aldehydes can be further oxidized, ketones can't. There's nothing above them. Okay, so if you oxidize, you can change either from an alcohol to an aldehyde and then further to a carboxylic acid. Or if you have a secondary alcohol, it'll change straight from an alcohol to a ketone and can't go any further. Now, once you become a ketone, you can go backwards. So that's the opposite of oxidation. So obviously that will then be reduction. So these guys can turn back from a carboxylic acid to an aldehyde and back from an aldehyde to an alcohol. Okay. Now, last thing we're going to do is our substitution reactions. So substitution, you are pulling something off and sticking something else on. So an example of a substitution reaction would be alkanes pulling off the hydrogen and sticking on your group 7s. So alkanes becoming haloalkanes. That's an example of a substitution reaction. And you also have the alcohols and the carboxylic acids coming together to make your ester. You pull off the OH and the H to make an ester, and you'll actually have water made as well there. And this last one, an ester, such as vegetable oil that we used, can be used to make a soap. We'll talk about that in a sec.